find the area of different shapes? We could use a formula, but there's a difference between knowing a mathematical formula and understanding why that formula works. I'm sure that some of you are familiar with the formula for the area of a rectangle. Here's a rectangle. It's got a length of 9 inches and a width of 6 inches. And if you know the area of a rectangle, you'll know that it's length times width. And that would be 54 square inches in this case. Now, if you don't believe me, you can pause the video and you can count all these 1-inch squares that I've got on this rectangle, and you should find 54 of them. So you can check that if you want to. Now, triangles are a little different. Right? If we have a triangle, it doesn't necessarily fill up those little 1-inch squares neatly. It cuts across a bunch of them. So how do we find the formula for the area of the triangle? Well, we're going to do it together now. And by the end, you will know not only what the formula for the area of a triangle is, but why it must be true. All right. So for this activity, you are going to need some rectangles of paper. I used construction paper. That's what I had available, but you can use whatever type of paper you might have handy. You are going to need a ruler for making straight lines and a pen or a pencil for marking out your triangles. And you will need scissors for cutting them out. All right, so what are we going to do? First, we are going to mark out our rectangles. Now, remember, there are different types, so we're going to mark out our triangles. There are different types of triangles. All right, this one is a right triangle. It's got a 90-degree corner, just like a rectangle would. Okay. Then we've got our acute triangles. All right. This one is an acute triangle. It's got 3 corners or vertices, if we're using fancy math terms, that are all less than 90 degrees. And then we have our scalene or obtuse triangle. And this is a triangle that's got one angle that's greater than 90 degrees right there. So those are our 3 types. What we're going to do is we're going to mark them out on the paper. Now, the right triangle is pretty easy to do. You just get your rectangle and you draw a line diagonally across it from corner to corner, and you'll notice that the corners of the triangle you'll get match up with the 3 corners of the rectangle. Now, I'm going to recommend that you do more than one acute triangle. So here's what one of them might look like. And you'll notice that we make our triangles so that they take up as much of the rectangle as they possibly can. So there's, they're a nice even size. And our cutoff bits we're going to keep, they're going to be important. So this one has a corner here that matches up with the rectangle, a corner here that matches up with the rectangle, and a corner up here that touches the opposite edge. Okay, here's another example of that. It just touches the edge in a different spot. You can see that they're different, but they're both acute triangles. So I'd recommend cutting out at least 2 of those. And keep the extra bits for all the triangles that you cut out, because you're going to need those. All right, now the last one is our scalene triangle, the one with the obtuse angle right there. All right, we start this one off very much the same way we start off the right triangle ones, by making a line from corner to corner. Then we make another line that touches the edge. All right, and this one is going to be the hard one. This is going to be tricky. So I'm going to recommend that you cut out two the same. You're going to need two of them to figure it out. And you're going to use the triangles, those two triangles, to make another shape that might help you. Okay, so that's what we're going to do. You're going to cut out your triangle, all your triangles, and you're going to take the shapes that you got left over and you're going to play around with those and see if you can figure out what the formula for the area of a triangle is and why it must be true and why it's true for all three types of triangles. All right, and I'm going to do a part 2 with the solutions.